I am on page 171, and we're looking at number 3. Marla is 20 miles from home at her uncle's house. She continues driving away from home toward her grandmother's house at a constant speed of 60 miles per hour. Graph an equation to represent her total miles from home. Now I'm going to add just a little bit to this. I think maybe they forgot to. After 1 hour. And there's a key word here, total. So I have a graph, a coordinate plane, and let's go ahead and set this up. So I have an x-axis. This is my independent variable. And this is the one that she can control. What's her name? Marla. So Marla decides how many hours she's going to drive. She can do 1 or 2 or 3 or 4 or anything in between. That's up to her. That is the independent variable. But depending on how much she chooses to drive, she's going to cover some ground. She's going to cover some miles. That is the dependent variable. And this is a very common ratio of miles over hours. And I'm going to scale this one by, let me see how many I can get on here. I think I'm going to do it by tens. So here's 10 miles, 20 miles, 30 miles, 40 miles, 50, 60, 70, 80, 90. All right, so they tell me that at the starting point, she's driven 0 hours, but she's 20 miles from home. So I'm going to plot a point here at 0, because she didn't drive any hours. She was at, is it her granddad's house? Her uncle's house. But she didn't drive to get there. At least they didn't tell us that she did. So she's 0 hours of driving, but she's already 20 miles from home. She's not starting at home. We'll assume that this is home. 0 hours, 0 miles, that would be the origin. That's her starting place, really. So this is the uncle's house. Let's do it that way. And then she continues driving at 60 miles per hour. So at 1 hour, where is she with respect to home? Because she was already 20 miles away. So at 1 hour, she's going to be 80 miles from home. She would be 1 hour of driving, that's 60 miles, but that's putting her at 80 miles from home because she started 20 miles from home. Here's what I want you to see. And this, once I show you this, I think this will click. Let's calculate the slope. Whoa, that's too big. In terms of rise, that's not big enough, is it? Let's try this one. In terms of rise, she did 60 miles rise in 1 hour. Okay, there's that big, huge slope. 60 miles in 1 hour. So the rise is 60, the run is 1. So you could say rise over run is 60 to 1. This is a huge slope because she's moving pretty fast. Okay, so the slope there is 60. The first question, it says to graph an equation to represent her total miles from home after 1 hour. So this is going to be the graph right there. If I had a graph that was big enough, then we could go ahead and graph a 2-hour one. But I don't have a graph that's big enough. So we're going to have to do this with an equation. And I'm going to use which equation? Let's do slope-intercept. Yes, because we know the intercept. So let's write out an equation. Y equals mx plus b. And let's do this pattern thing that we do. So y is the distance from home, the miles. M, we found the slope to be 60. X is the number of hours, and we can tell baby B by looking. Baby B is at 20. That's her starting point. So there's the equation that I'm looking for. Once I have that equation, I can find any number of hours I want to. If Marla drives for 2 hours, how far away from home will she be when she is at her grandmother's house? So we're going to say y equals 60. When x is 2 hours, she will be 120 plus 20 is 140 miles from home. So I like option A on this one. That is not an easy question. It really isn't. You have to have a pretty good grasp of what you're doing here to nail that one down. So it's a good one. And I think I'm going to have to stop this video and go to bed. I'm very tired. All of the videos you've seen to this point have been done in one day. So I've been filming all day long, and I think I'm just going to pick this up again tomorrow with problem 4. Actually, we can do 4 right now. It's not too bad. Let's go ahead and do 4, and then I'm going to go to bed. So negative 4x minus 3 is 13. And our instructions are to solve for x. So I'm going to put this in here. I see that my x is on this side, and I want everything else on this side. All I want left is an x. So everything else needs to come over here. So first I'm going to move that 3. Let's do a plus 3 to both sides and cancel. So I'm left with negative 4x equals 16. And then I'll divide by negative 4, because remember, all we want is the x, and that will be negative 4. So the solution to this equation is x is negative 4. All right, you won't notice this, but I'm going to get some rest, and then I'll come back in the next video and we'll pick up with Kellen and the soccer balls. I hope you have a really good day, and I'll be back soon. Bye-bye.